live steam locomotive that I have recently acquired. I was able to do some research and I got help by a few gentlemen who had a lot of knowledge about this locomotive, and I would like really to thank them for what they have shared with me. As you can see, it sits on a HO gauge, so big difference between gauge and scale. Gauge is the spacing between the rail. Scale can vary. For example, if you do a narrow gauge locomotive, you will have a bulkier locomotive than a standard scale. So, HO gauge, it's a little bit oversized, which is typical of the British OO scale. They call that also sometimes OO gauge, but it should be OO scale locomotive. To be exact, and we are going to speak a little bit more about that later, I'm going to show you an article here about the locomotive. The exact scale is 4 millimeters to the foot, so that's your conversion rate. But let's go back to the locomotive. Some of you are going to think it's not possible. Is it really live steam? Yes, it is. And I'm going to show you that it's running. I am running it on air for now. And I'm going to ask a question all the time if I should fire it up or not. When you look at this locomotive, it's really something extremely accurate. So perhaps for you to be able to enjoy the details, I'm going to remove the burner. There we go. And then I want to make sure, if I magnify a little bit, that it's not blurry. So 4 drivers on each side, and the power is transmitted to the second rank of driver. The thing which is interesting to see, and let me try to light up exactly, it's the valve gear mechanism, because it's all happening there. So this is here, you have eccentrics, and when you rotate the wheel, so let me rotate from the back, it's pushing rods, and here we can see it better. Are you able to see? So if you look in this area, you are going to see the slide gear mechanism which is moving. Okay, let me, oh, here we go. You see? And it's the same on the other side. We are speaking per the blueprints, and I'm going to share the blueprints with you about 1/1000 of an inch accuracy for the engineering of those mechanical pieces. Obviously, when you look at the locomotive, it has never been fired up. There is no indication that there was any kind, perhaps slightly, yes, any kind of flame or smoke that reached the bottom of the boiler. So I may disappoint you, but I think I'm going to continue to test it on air, because my experience with live steam locomotives is that you damage them when you run them on live steam. And this locomotive is so complex in the machining that in case something would break, I would not know where to go to be able to find an expert to repair those parts, to dismantle, to realign. So it seems that the wicks may have been tried, but I'm not even sure, because typically you would see some black. I am wondering if they were not tried outside of the burner, the wicks, and then put inside with the black color, because there is absolutely no sign that it has ever been tested. Now, what I would like to do is to speak about the individual who has designed those locomotives. So let's see. I'm going to go back to the computer. His name is Archer A. Sherwood, and he was very well known. He has even designed a live steam locomotive at the scale of 1 to 240, as you can see here. So you want a little bit smaller than this scale. And he is known also to have designed a locomotive, not live steam this time, that was scaled 1 to 1/480. I won't recognize Dean, who has sent me this article that was published in Model Engineer in 1960. And it's a blast, because I have a full description of the locomotive, from general directions to all the details of the parts and the blueprint. So the name of the locomotive is called Plain Jane, and it's 4mm scale to the foot. So you are going to see, I'm going to scroll. By the way, there is a link below the video to my web page, my live steam web page, where you can see the connection with the article, so you can access to it. We can compare the locomotive with the blueprint. This is the finished one. So the Plain Jane is a simpler version. The Ronda is more sophisticated. That's the one that you see at the bottom. The Ronda has more, I would say, outside fittings to make it even more a locomotive, but the base is still the same. You have a view of the front, and I am showing the front. So now let's continue to scroll down. They recommend that you start with the cylinders, because they said that the cylinders is the most difficult part, so the cylinder group. So basically, when you are done with the cylinders, you have done the hardest job, and then everything else, it's kind of downhill. It's much easier to do. And you see, this is the beauty, is that for this engine, I have all the details, and your typical model engineer communication with the way to do it. So not only you have the final blueprint of the part, but when it's difficult, they tell you how to do it on the mill or on the lathe or other techniques. The chassis is very important, because this is the stiffness of the locomotive. So they say that you can take some liberty with a lot of parts, but not with the chassis. And the wheel spacing is different than the prototype, and that's by design with the model. So now we are starting with the boiler, so still the chassis, the cabin and the tank, and the boiler finally. The boiler is superheated, as you can see. There is a pickup point at the highest point, and then superheated above the burner. It is superheated above the burner. The pistons, the rear cylinder cover, and imagine that all those parts are so small. Again, a view when you start to put together, the entire cylinder and slide valves, all the parts for the valve system, the eccentric, how to set it up. So you can see the difference between Honda here and plain Jane. Honda, you are going to take the time to do the spoke wheels. Plain Jane is more, okay, we are not going to go into the details. We want to fire that locomotive, so we are not bothering with the details. So it's more a functional locomotive. You can see immediately that here with the coupling rod there is a challenge. The wheels and the accuracy of the mechanism need to be perfect because it's a straight rod with 4 holes to the wheel, so it does not forgive anything. This is the quartering system. I am not sure when I am looking at mine. Okay, so mine on this side, the wheel, I assume they are either pressed or welded, perhaps pressed. And when I turn on the other side, you are going to see that the builder has put screws. The screws do not appear, you see, 1, 2, 3, and then believe me, there is a 4th here. The builder may have quartered them and locked them with a screw. I am not sure, but this is not the way it's described in Model Engineer. By the way, in Model Engineer they say that you can do whatever you want as long as it's working. They just warn you on the key points so that the machine is going to be functional. Here we have the connecting rod, which is on the second set of wheels. As you can see here, there are a lot of consideration if it should be on the second or the third. And they are speaking about the torque and the way the torque goes to the wheels. The article is very, very interesting because it covers everything. Here we have the needle. The needle here that I'm going to show you, you find in front of the steam locomotive here. So this is, it's both for the oiler and to adjust the quantity of steam that goes to the cylinders. This is the firebox cover that you have here. And then we go into the burner. The thing which is very interesting, and you see that there is a lot of experience. So the alcohol goes at the bottom, but you have a second reservoir here that you can see. And here actually they tell you to put water or even more, an ice cube, so that it cools down the alcohol, so that the alcohol is not boiling. And for those who have been running spirit-fired locomotives, you know that boiling alcohol is a problem. So again, a very well engineered locomotive. The smoke box on the left that you see here. Again, the firebox top cover. They call that the lamp, whatever. And then at last you run the engine. So I'm going to show you the engine running on air. You can give me your opinion below the video. I'm sure that half of the people are going to tell me that I should fire it up, the other half that I should keep it the way it is. Right now I am more leaning towards the second position, but if there is enough demand I may try to fire it with live steam. As you can see, I am absolutely thrilled to have had all this information and documentation, and mostly it's due to the support of you guys, the viewers, both on Facebook and YouTube. So I want to thank you a lot for your contribution to this video. Now let's say a few words about the man who has built this locomotive. I don't know if it's Arthur Sherwood himself or somebody who took the blueprint from Model Engineer, which I think it's more likely. But I can tell you, the man who built this locomotive, and perhaps I should say the man or the woman, but likely the man, has done a fantastic job. I've not seen any flaw, any shortcut. It shows a mastering of the thousandth of an inch, which is absolutely perfect. The weldings are very good. For example, if you look here at the cylinder, I used to have a small Decauville, also HO, and it was not as well manufactured. I've not seen any defect on this locomotive. So we are going from an extremely good design to a perfect machining, and today I consider that I'm the lucky custodian of this locomotive. And this is one of the reasons why I don't want to fire it up, because I fear that I'm going to destroy it, or damage it at least. I want to take the opportunity to speak about my late, I say late, not that it's deceased, but unfortunately I have sold it at a time where my focus was on other interests. I still had the same passion for live steam, but I was doing other things, and my Decauville narrow gauge, and you can see some of the photos. This one, I did fire it up. Unfortunately, at that time we were not doing home videos, but you can see in the last photo that there is smoke behind the locomotive, and this one was really working. Unlike the GWR, the 280, it was going only in one direction. But one day I found a gentleman who had made one and did the full wall chart with the link where you can change the direction of the locomotive, and this is the video that I'm going to include in this one for you to appreciate. So all credit to that builder. The best way to start in the HO gauge live steam system is to buy one of the Hornby OO scale locomotives. They are easy to find. There were 14,000 made, and most of the buyers actually they just kept them in the box. I think they got interested at the beginning, but it's a little bit too complex to operate. This is a system which is unique where, as you can see, the boiler is in the tender. The steam is heated in the tender, and there is an electric regulator which is driven by a transformer and by the rails, which is going to allocate the steam to the cylinders. So the valve gear actually is not real, and it's the internal electric distributor which is allocating the steam, and it's fairly smart because you can go forward and backward and different speed. So good opportunity here to get in the hobby with fairly available live steam locomotives. Next is Steamcraft, very marginal production in the 70s and the early 80s. I don't think that they are the real deal. If I have understood well, there is an internal cylinder with gears. It's still a live steam locomotive, but they are extremely hard to find. So I would rather point you towards Hornby, which is easier to find. You can find also some batches. Some are made in Asia. It seems that this one was made in Switzerland, which are very simple, often based on the rocket of Stephenson, which is another way to get into the live steam HO gauge hobby. An important consideration for live steam in HO gauge is the speed of the locomotive and its ability to take curves. In general, it's recommended to load heavily behind the locomotive with many rail cars, because sometimes it's a little bit an all or nothing. It goes very fast, and if you don't put a heavy load behind, it will miss the curve. The other point, and as you can see, I am with Marklin M gauge, I am on the widest curve which is allowed, which is the 3900. And look what is happening with this one. So the biggest reason, the number one reason, is because it's a 280, and up it's sliding and escaping the curve. So I won't be able, and I have hard time even going backwards, to put it back on the track. I need to reposition here. So I can go straight with my track, but I don't have a wide enough curve for this kind of straight 280 chassis, unfortunately. Up, you see? And it doesn't go back alone. It needs to be repositioned by the finger, with my fingers. So large radius and a lot of weight behind the locomotive to slow it down. Well, it's time to conclude this video. Unfortunately, I would say, because I really enjoy sharing with you guys my passion. And perhaps a last view of this locomotive. Thank you so much for watching this video. If you have any questions, please ask them through the comment section.